I will try my best, but the good things is I don't think I need to worry too much about time because Xiaoqian already just taken care of part of the things which I originally supposed to mention here. And so what I'm going to talk about here is our linked R1 project with iDash, and it's together with UC San Diego. On the IO front, I myself, Xiaofeng Wang, and my colleague Hai Shitang. On the UC San Diego front is Xiaoqian and Lucina. So what we are trying to do is privacy preserving, sharing, and analysis of human genomic data. Yeah. And so the two just as mentioned on the title, right? Two things we are trying to do is how to develop a scalable and a privacy preserving technique to analyze a large amount of data in an untrusted environment, just like Amazon EC2, right? And the second thing we're trying to do is we need to find a way to share the data using NIH Center without leaking out sensitive information, just like and patient's privacy. So the way to do that, on the data analysis front, what we're trying to do is, and the simplest way to do these things is you want to use public cloud, use their computing resource to analyze data, but you don't want to leak out sensitive information. The simplest way is you can use encrypted data. You can try to do computation data analysis on encrypted data, right? And there are some generic technique which theoretically work, just like homomorphic encryption and secure multi-party computation. But the problem here is for those approach, if you want to run them on top of those huge amount of genomic data, the current technique is just not there. It's gonna take a long time. And so what we are trying to do is we want to make them more practical. And the idea is, we take advantage of two observations. The first is, the cloud is organized in this hybrid way, right? And you can outsource computation to the public cloud just like Amazon EC2. But in the meantime, within your organization boundary, you still have a bunch of computing resource, which essentially is kind of just a private cloud. So the question is, can we just another private net organization to do some type of work to simplify the task, and make the computation on the public cloud over encrypted data feasible. And the second thing is, although those techniques, homomorphic encryption, secure multi-party computation, in general is very heavyweight, but if you're looking at the unique feature of genomic data, there's a chance you can come up with a lightweight crypto technique to simplify the whole things. So this is what we did, and the first things we're working on is privacy preserving risk mapping. It's the first step for any genomic data analysis, right? And you have individual risk extracted from human blood. You want to put it into the right place, and by comparing it with a 6 billion reference genome, it's a huge amount of computing task. But if you do this in homomorphic encryption in a straightforward way, right, it's very difficult. It takes just many years even to compute a single data set. But what we did is do computation partition. We separated the part of computation which can be work on the public cloud in the crypto forms to the public cloud, while in the private cloud, and we do some work on the plain text data. In this way, we show, and we can come up with a very efficient technique which can, have the task done, with regard to one over, 10 million reads, just within 1 hour. And another task we are working on is microbiome data filtering, right? When you extract those if you want to working on those, bacteria, microbes DNA, and the DNA oftentimes is contaminated with human DNA. You want to filter out the human DNA, right? And to analyze those bacteria and DNA information. But the problem is, it contains a lot of sensitive information. You cannot give the data directly to the public cloud, just like EC2, right? Because and the human DNA part can be used to identify the person, identify the host. Well, the bacterial part just tells what kind of bacteria that person has. It's very sensitive, but and our research show using this privacy preserving the similar technique as we developed, and that's very promising. We can do this privacy preserving microbiome filtering. Another things we are doing is how to do, the data, dissemination, and through an IH center, just like iDash, in a privacy preserving way. I think the first problem we're looking at is something like this. if you are working on some, just and genomic studies, for example, GY study, right? And you what you want to do, the first thing is you want to collect a lot of data set. Yeah, the first part is just and the data set discovery. You want to find the most usable data and for your research. And the straightforward way is you just go to just the old data source, data owner, to sign agreement to get all these data set. And there could be hundreds of data sets out there. You have to sign hundreds of agreement. You have to wait a long time before you can even start the research. And just also it could be end up with just only a small set of data. Is useful for your work, right? So that means you unnecessarily just undertake a lot of liability. Also from the data source viewpoint, data owner's viewpoint, and they give you the data, although you sign agreement, but they expose their patient to kind of risk, right? But if the data turns out to be useless to your research, so it's just a waste. So the question is, how are we going to solve this problem? And we come up with the idea that just we will allow those data owner to release a small set of pilot data, right? And those pilot data itself, just has been is synthesized data. They have been anonymized. So looking at the pilot data, you will not get any information about an individual patient. But the pilot data preserve one utility. That is, you can compare the utility of individual data set and one data set with the utility of the other data set. So what you can do here is you can run your algorithm on top of those pilot data, and then we provide just an estimate algorithm. Using this algorithm, you analyze and you can find out, yes, maybe the data set from UC San Diego looks more useful to my research than the data set from Indiana. If you can get this information, you don't need to sign 100 agreement. You can go straight to San Diego to sign agreement just to get that specific data set, right? So we developed this technique, just in the first year fund, and we analyze it. It works, and for some GY study, it looks very promising. And but further research you definitely need on this, in this area. And the second thing, which Xiaofeng is already, just and give a 10-minute talk on that. So I don't think I need 10 minutes, just 1 or 2 minutes, right? The second thing we want to do is we want to understand, just if we share the data in a privacy preserving way through the center. So what's the best way to share the data? You can share the raw DNA data, or you can let a center to do the computation on the researcher's behalf, and then and share the result. Of course, the result also need to be anonymized to protect the privacy of patient. And the way to do it, the first step is we organize this competition together with UC San Diego. So we have and 5 teams attend this competition, right? And we have 2 tasks. The first is we're looking at the possibility to share the raw data. The second thing is we're looking at the possibility to let I- to compute the result and share the outcome of computation. And the result, as Xiaofeng has been explained, is looks like the first approach, sharing raw data, is very difficult. Even for a small set of data, in the end, what we found is in order to protect privacy, oftentimes you have to anonymize the raw data to the extent that completely loses utility. And the second approach, that is that I should compute the GY's analysis on the data and give the result back to you, of course with some anonymization technique to protect the outcome. Looks very promising, just like what Xiaofeng demonstrated. And if you just release the most top 10 most significant data with very high chance, and for some technique, just like the technique proposed by UT Austin, it's almost with probability 1, and you can release the data which is significant. It's indeed significant without leaking out any sensitive information. Yeah, since the time's up, I'll quickly wrap up, what we are doing. And one thing we are doing is we're looking at the risk in the other data, just like proteomic data. Yeah, we found it itself also contains some identified information, but in the meantime, there's chance we can remove those identifiable markers without affecting its utility. But first, starting it on this direction. Another thing is and we are gonna we are gonna organize we're gonna do a make a portal, just and to provide information to allow the researcher, just whoever interested in this area will provide a material to help the researcher and to working on this important direction. Okay, that's all my talk.
Thank you. Any questions while Jane gets set up about this? All right.